I used to be a macroeconomist. I was based in this country, covered a lot of economies. And when you look at the macroeconomy, what you see is the collective action of a lot of people. In this country, 9 million people. The tricky thing is that when I started to do evolutionary behavioral science, I realized that there is a disconnect between our heads and the number of people who are in one economy. Yeah, so if you look at, let's say, downtown Budapest, this area here in the middle, yeah, the population density is very, very high. So those of you who live here, you know that you don't know everybody. Yeah? You are a human ape, so your social cognition does not allow you to track everybody around you, unlike in a small village. Yeah, if you're a small village, you know everybody. Yeah? So I thought, okay, so what is, if downtown Budapest was the unit, and the population density in downtown Budapest was the unit, how big would be all of humanity? So it turns out that if all of humanity, all the 8.2 billion people lived in Belváros, then we would cover not only Hungary, would be Belváros, but all of Austria, Czech Republic, Slovakia, a bit of Ukraine, all of Romania, Serbia, Slovenia, Croatia, they were all, would be fully covered like downtown Budapest. Yeah? Gosh, that's a very difficult thing to think. So I thought, okay, so if I have a love and 2 kids and a few friends and a bit further away a few friends, so let's say I now have maybe 50 people who are in my immediate social relations. Yeah? 50 people that my brain can process as my social connections. Okay? How many people will I know in all of my life? Yes, I'm quite an outgoing person. I travel a lot. So more than the human average. The human average is like 150, 200, maybe. But maybe we here are worldly people. We move about. So when you die and you look back, then have a list of all the people who you will have had a meaningful connection. I'd say 300, 350 people, yeah? So 400 of us, quick count. So that's 400 times 350, it's 140 people, 140,000 people. Try to imagine 140,000 people in your head, yeah? It's unthinkable, yeah? Unthinkable. This is how many. This was Madonna's largest concert in 1987, a feminist icon. It's in Paris. Look at this crowd. As imagine you had a meaningful conversation with every one of them. Impossible to track. Your brain just didn't evolve to track them. So imagine, this was 87, so Gorbachev was still the Secretary General of the Soviet Union. Ronald Reagan was still the President of the US. Imagine that she gave a concert to another 140,000 people next day, the different 140,000 people. And next day. And next day. Until Hillary Clinton goes to Beijing and says, human rights are women's rights and women's rights and human rights. And next day. Until May the 1st, 2004, when Hungary joins the European Union. A different 140,000 people. And next day. Until yesterday. And today. And tomorrow. Until the day I die. Until the day the last one of us dies. Until the youngest of our kids dies. Until the youngest of our grandkids dies. She gives a concert to 140,000 people until the summer of 2151. That's how many 8.2 billion people is. Our brain cannot possibly conceive this. The problem is that we together, the 8.2 billion of us, have some problems. Because the planet that's right now ruled by us and guided by us has at least 5 existential existential challenges. And we have solved so far, or miraculously got solved by one. And we have 4 to go. Let me show you the one that was solved. So this was the Club of Rome. This was the first time there was a global model. This was in 1972. The Club of Rome created a model of population growth. And they thought the problem that humanity has is exponential growth rate. Exponential growth of the population. So you can see here, the black is the population. You see it's exponentially growing, but at one point food per capita peaks, pollution peaks, and then the population comes down because there won't be enough food, and there's going to be too much pollution. So we will die. They were wrong. The population pressure that everybody thought was going to be there went away. Went away on a very simple thing. So when women are free to go to school, and there's a school to go to, and the women are free to go to the market and get a job, they have fewer kids. Here's some evidence for that. This is from all of humanity. The x-axis is the mother's education level, and the y-axis is the number of children. Straightforward connection. And because humanity is since the late 19th century, the number of years in schools increased, both women and men, but women as well. Population is going down. So one problem is solved. But it's not only the question whether the growth rate of population since 1950 to now has been going down, and hence the population peaks. Yeah? So in 1972, they thought that the population is going to go exponentially, and gee, look at this. It's peaking. It's going to peak somewhere between 9 and 10 billion people. And with that, hunger is going away. This is the absolute poverty measure for the whole species, everybody together, since the early 19th century to now. So the early 19th century absolute poverty, depending on how we measure it, was around 90%. 9 out of 10 people were at the threshold of dying from lack of resources. A bit of drought, the locusts take the crops, and we're going to die of starvation. When I grew up in 1970s and 80s, there were still some stories about mass starvations. Not anymore. So that 90% from the 19th century went down now to about 7%. Still quite a lot of people are at the edge of death. Absolute poverty is still quite high, but not what it used to be. And there's a bit of restructuring going on. Europe and the US is the orange line in the middle, the number of persons in billions. That's clearly that the 2 blue lines, which are East Asia and South Asia, and the pink line, which is Africa, restructuring the planet where the people are living. Yeah? So population goes away, there's a restructuring happening. Some of it is migration, some of it is just we see how the economy is changing. So that's the good news. The bad news is that all of this, although the exponential growth is going away, still means there's a lot of people. So look at all the biomass distribution of the planet. Like everything that lives, and just count their kilos. Actually, you call them carbon atoms, but okay, you count their kilos. The green is plants, bacteria, archaea, viruses, fungi, and there's animals. Can you see the little gray triangle? There's the animals, yeah? So let's focus on the animals. Arthropods, insects, mollusks, nematodes, and I put a little picture next to them so you know what they are. Fish, wild birds. Can you see the wild birds? Heron, Goya, stork, yeah? Wild mammals, Bambi, humans, and livestock that's feeding the humans. So this is a single species, one mammalian species, you. And then whatever meat you want to eat. Look at the size of the livestock compared to the wild mammals and wild birds. So the human, I don't know what's going on there, the human body mass is out of proportion, but that is not necessarily the issue. The issue is something else. This is the child per woman, fertility on the y-axis, and this is the GDP per capita. 1990 to now, the child per woman is going down, and GDP per capita is going up. Fewer kids, richer societies. Yeah? Similar pattern. The annual population growth is going down. We're going to 99 to 2000, mid-2000s. All of these are species level, and everyone together. Population growth is going down, and the malnourished people are going down as well. So we're getting rich. Just a sec. We're getting rich, but as we are getting rich, we are changing what we are doing. And oddly enough, although we eat less, the total impact on the planet is increasing. So this map I have on my wall as a daily reminder. And I suggest maybe you want to do it as well. So this is the human appropriation of net primary production. That is, how much of new biological growth is taken by our species. Some of it is negative. Look at the blue is negative. So bits in the desert, like in Saudi Arabia, is having irrigation systems, capturing the rain, and growing new stuff from the desert. That is captures, that's net that we are contributing. But some of it is dark black. Look at India. Look at bits of Western Europe. Actually, look at Hungary. We are taking out much more than we are giving back to the Earth's life. Yeah? As a consequence of that, the ecosystem of the planet is collapsing. Yeah? Who remembers the way the banking crisis happened 15 years ago, 17 years ago? Do you remember it? One bank falls, and then this bank bankrupts, and then hits the other banks, and then hits the other banks, and hits the other banks. So there's a network effect, yeah? And the graph, the network of the banks collapses. The same is happening in ecological networks. We have a quick word for this. So what we say is that there's an extinction wave, but it's just one measurement. It's a systemic collapse of the ecosystem. Look at this is the past 40 million years. So the x-axis is going back in million years. The rise of complex life. And looks at what percentage, the y-axis is a percentage of species that are going extinct. So depending on how you define it, maybe there was 1, 2, 3, 4, 5 extinction waves in the past. Very clearly, there's one now. We just don't know where it is going to go. 70% of frog species are already gone. That question mark is going to be somewhere really high up. We don't even know. But the scariest thing about it is that if I look at the speed of collapse, if I look at the speed of collapse of the past 5 collapses of life, which we can estimate from the fossils, from the archaeological record. That speed, imagine you know where the parliament is, yeah? Imagine there's a mosquito flying towards us from the parliament. There's the speed of the fastest collapse of the ecosystem, Earth's life in the past. Next to it is a fighter jet at full speed. There's a current collapse speed. If we are not waking up in the morning being worried about this, we live in utter ignorance. Because we are in the middle of an extremely fast collapse of the ecosystem. Actually, these numbers are calculated, yeah? So it's about 1,000 times. So I looked up the speed, a mosquito speed. I had to pick which mosquito species I'm picking. And which fighter jet, of course. Anyway, so that's the actual speed. So we have 5 of these challenges. Exponential population pressure is thick, but because we are a lot of them, remember the biomass data, what we do matters. Yeah? The easiest is controlling the physical processes of the Earth. Sometimes we put a tag on it. We call it climate change, because we need a tag in our heads. It's actually a control of the processes. Yeah? And think about it. Carbon, we know this atom really well. We know its molecular structures really well. We know where it is, where it comes from. We know where it is. A lot of it is in our bodies, by the way, on the chairs, on the floor, in the air. And we know where it goes. These are real plants. I'm not sure these are not real plants. Those plants out there, yeah? We know all of it. The easy problem is that, and we're failing at controlling it. Even more, we're failing at looking ahead beyond the next 50 years. I took the bother to download all the data, and I took the bother to start modeling the Milankovitch cycles, which is a long-term climate cycles on the planet. It's very clear, and if you'd like, I can show you my own calculations, because so many people are talking about it. I want to check that the planet is clearly warming. It's very clearly associated with human action. It's very clearly going to get very cold within the next few thousand years. To which what I hear is that it's obviously humanity will have a temperature control for the planet at one point. And the sooner we do it, the better we're going to do. So that's one unsolved problem. The second unsolved problem, which is much, much more complicated, is what I just talked to you about, the collapsing ecosystem, the collapsing biosphere. We know how the climate works. We have no idea how the biosphere works. We know the basics, the surface. We have an impending inequality revolution among the 8.2 billion of us. If you look at a little bit of our inherited behaviors of how a human ape regulates social inequality, then it's very clear that the only reason we don't have a full-on revolution in the global society, because we haven't perceived it yet as one. We will have a problem. We already have some problem. If you look around what happens in politics around the world, a lot of it has to do with status anxiety. People are anxious about where they are in the status hierarchy. Human apes are anxious about where they are in the status anxiety. And I'm sure many speakers are talking about AI here. We need to find a way to somehow integrate this super useful tool, the out-of-control abacus, yeah? You know the abacus, yeah? Amazing technology to do something that is, you can do faster for some weird reason on this wooden tool than in your super smart brain. I still don't quite understand. How is it possible? There's a very, very simple thing. I've got this computer up here, millions of times faster, and I'm still doing it here. Anyway, we are doing it here, and the computing intelligence is speeding up to our speed as we speak. We need to figure out how we deal with that. So 5 existential challenges, 1 down, 4 more to go. The good thing is that we know we can design social technologies for ourselves. Some people say the market is going to solve it. Some people are going to say some global governance is going to solve it. We can design something. In the past, these social technology designs came more by trial and error. But now, if we understand what the problem is, maybe we can think about how to design solutions to this by thinking about it. So that's your homework. Good luck.
Thank you so much. That was awesome. Take a seat over there.
I thought we have 2 chairs, one for you, one for me.
Oh, they don't pay me enough to sit down.
Do you want to sit down?
No, do you want to sit down?
They just pay me barely enough to sit down, okay.
Okay, how about I sit down and then I answer the questions directed at you.
Amazing.
Yeah, you're about to sound very, no, seriously, take a seat. Do we have any questions in the audience? Raise your hands, please. Yes, we have a question over here, black t-shirt.
And my question would be about women's education. You've mentioned it and how it solved the population growth problem. But I think it only applies in Europe and in Western countries. And at other regions, due to religious or not developed aspects, it is not in their interest to educate women. So this population problem is not solved. So what do you think about that, and what could be the solution? Thank you.
Thank you for the question. I've written a book on gender equality, inequality and equality. It just came out. If you come to, there's a question and answer after this, and I will bring a copy, so the best questioner will get. If you are the only questioner, you will get it for sure. So what you said used to be how people thought about this. It's not true anymore. Is the IT colleagues can Google the TFR of Oman. Please put it on the stage. Otherwise, I will show it to you.
I'll do it right now. TFR, no, I can't.
TFR Oman.
I can hold up my phone to the cameras. How about
Okay, amazing. I don't need this.
There we go.
Yeah, that's it. So first, let me show you something. This is the x-axis, yeah? This is time. Let's say 15,000 years ago here to now here. This is going to be from speaker to speaker. That's the x-axis. The y-axis is the total fertility rate, the number of children born to an average human woman, average on the species. Cool? Yeah? So 15,000 years ago, before the farming revolutions, it was 4.5 to 5 kids on average. So forager societies, they vary a lot in the number of kids, but it's about 4.5, 5 kids per woman. Farming appears 11 different times on the planet, goes up to 7-ish, 7.2. Stays like that, stays like that, stays like that, until fertility starts falling, first in France, and then Western Europe, first in the 18th, and then rapidly in the 19th century. But the rest of the world, as you suggested, is still up. And then, from after the Second World War, it starts coming like this. And now, it's 2.5, species level average. So it can go extremely far. The reason I wanted to show you Oman, because it's the clearest case happened in Oman. So Oman got rich in 1970 on the back of oil. Before that, the average number of kids per woman was 7.2. Then there was a very enlightened sultan who increased it, who started to implement clinics and healthcare units. So 7 to 2, in 10 years, by 1982, went up to 8.2 kids per woman. Why? Can you guess why? Why did clinics solve this, increase the number of kids? Women stopped dying in childbirth. Maternal mortality went down. And from 1982 to 2005, just a little bit more than 20 years, it went down from 82 to 2.6, the beautiful S-shaped curve. A speed up, a beautiful illustration of what happened to humanity in one country. And now it's 2.6. Why? Because they were investing in schools, not only for boys, but also for girls. Women's rights ended up girls and young women getting education, getting access to the market, and then access on the market, getting access to contraception. And the control of the resources, which resulted that they took back control of reproduction. In foraging societies, reproduction is controlled by women, all the reproductive decisions by women. The same in the matriarchies. It's only these odd phenomena, the patriarchies that emerged for the past few thousand years, but it's reversed. So this is the case in East Asia. This is the case, actually, last fertility is in South Korea right now, 0.8 kids per woman. India is coming very, very fast. It's already under 3. All of South America, same story. The only part of the world where it's still relatively high, but already, so this is the curve, and so they are like here, but coming down, is sub-Saharan Africa. Everywhere else, this is the story. So the population pressure truly is going away. The question is how we organize ourselves in what we do.
That was a great question, very eloquent answer. I'm sorry that wraps up the time we have here.
I'm sorry, that was such a long answer.
No, it's all right. That's all the time we have here with Tamás, but the conversation continues in the library outside for a brain-picking session. So if you want to ask some more questions, go ahead, head over there. So please give a big, warm welcome to Tamás Dávid-Barrett.
You are a great audience.